This is questions 1, 3, 5, 12 and 14 in exercise 8.1 in Project Maths 3A. In this video we're going to be looking at differentiation, and specifically differentiation by rule. Now differentiation itself is a means of calculating the rate of change, in this case of y in respect to x in given functions. But for this video we're just going to look at the actual rule and how it is applied rather than applications of it for the moment. So you can see the rule up here in the top right of the screen, where we've got if y is equal to x to the power of n, then dy dx, which is the differentiation of that, will be equal to n times x to the power of n minus 1. Or if y is equal to a times x to the n, where a in this case would be an actual number as opposed to just a variable the way x is, then dy dx would be equal to nax to the power of n minus 1. In other words, when you're differentiating, you're going to multiply the power by the coefficient and then reduce the power by 1. So let's just see a few examples of this. If you look at question 1 here, we've got y is equal to x to the power of 3, which means that dy dx, for that we're going to take our power, which is 3, and multiply by our coefficient, which is 1. So 3 times 1 is 3. And then we're going to write in our x, and then we're going to reduce our power down by 1. So it was to the power of 3, and we reduce it down by 1, it becomes to the power of 2. And that's it. That is dy dx for that particular function. Let's look at question 3. Now in question 3 we've got y is equal to 8x. So the way we can look at this is that this is actually x to the power of 1 up here. You can write it in if it helps you at all, but there's no need to necessarily. So we've got here is we're going to go our power to multiply by our coefficient. So 1 times 8 is 8. And then we can put in our x, and we reduce our power down by 1. So from 1 down to 0. But the thing is, x to the power of 0 is just equal to 1. So what we have here is 8 times 1, which is just 8. And it's perfectly acceptable when you're differentiating a function like this, which is a linear function, to jump straight from the first line where we've got y is equal to 8x down to dy dx is equal to 8. These two steps in between where I showed the x to the power of 0 and 8 times 1 are just explaining how we got to the answer. It's perfectly acceptable to just say that from this dy dx is equal to 8. Now for question 5, there's two different ways to explain how question 5 is going to work out. So we've got y is equal to 2. So what we have here is dy dx is going to be equal to, okay, now what we actually have here is this is 2 times x to the 0. Because as we saw previously, x to the 0 is equal to 1. So what's going to happen here is we go power times the coefficient, so 0 times 2 is 0. And then we have x, we reduce our power down by 1. But it doesn't matter what we've done to the x after this, because if we're multiplying it by 0, we're just going to get 0. And the other way of looking at this is, each of the times we've differentiated so far, we found the rate of change of y as x changes. So for example, in question 3, as x goes up by 1 each time, y is going to go up by 8 each time. So it's changing 8 times more. But the thing is with question 5, no matter what value we sub in for x in question 5, y is always going to be 2. So there is no rate of change on a constant, which is a number with no x attached, which is why we got a 0 for that. Now what we're going to do is we're going to take a look at two questions where there's more than just one term in the expression to be differentiated. So we're going to take a look at questions 12 and 14 just here. So we'll start with question 12. Now when you're given an expression like this, what you do is you take each term individually and you apply the rule one at a time along the way. So for this we have dy dx is going to be equal to. Now when you're dealing with a fraction, there's two ways you can go about dealing with a fraction depending on which way you're more comfortable with working with. You could firstly, if you want, just apply the differentiation to the x on top and leave the 10 on the bottom as is. So x squared becomes 2x, that's still over 10. And our 3x, when we differentiate it, we just get 3. And then our 2x over 10 is just going to be equal to x over 5 plus 3. Now the other way of doing it, if you wanted, would be to say that y is equal to, and then you split the x squared over 2, x squared over 10 up, so you're going to get 1/10 x squared plus 3x, which means that from here, dy dx is going to be equal to 2 times a 10th, which is a 5th, so it's 1/5 x plus 3, but 1/5 x is equal to x over 5, so we get x over 5 plus 3, whichever way we go about it. So that's question 12. And then in question 14, 3 terms to work our way along. So dy dx is going to be equal to, so in the first one we've got 3 times the coefficient, which is 1, so it's 3 times 1, which is 3. And we put in our x, and we reduce our power down by 1, so it goes from to the power of 3 to the power of 2. And then plus here, so plus here. And then for the next one we've got our power, which is 2, times our coefficient, which is 4, so we're going to get 8. And we put in our x and reduce it down by the power down by 1, so reduce from 2 down to 1, so that's x to the power 1, which is just x. And for the last one, we have 1x to the power 1, so 1 times 1 is 1, and if we reduce our power down to 0, we get x to the power 1, which is 0, which we previously saw is just equal to 1, so there's no need to write in x to the 0. So that's dy dx on 14. And that is that.